right. Hey everybody, how are you all doing today? Really excited to get started with today's webinar. It's going to be just a great event, like talking about a success story that we had here with the Autodesk University Smart Badge and going, diving deep into the details. I'm just going to jump right into things here because we have an hour where I want to spend a lot of that time, talking about the work that we did, going through these details. But I also want to save time at the end for a live Q&A session with myself and Peter and you, the audience as well. But let's lay down some groundwork. We're going to start off with some introductions, some brief backgrounds about our companies, and just jump into the design and manufacturing of the Autodesk University 2022 Smart Badge project. We're going to take a really deep dive into the initial design for manufacturing feedback, especially on the injection molding stage, including the tooling strategy. So we're actually going to show you what the tool looked like after we went through the DFM stage and kind of how that produced those parts and why we went that direction as well. We're also going to touch base on 3D printing for production. This was a mechanical complement. So beyond just the production of the injection molded enclosures, we actually built features using industrial 3D printing processes as well with the Smart Badge, and we'll touch base on that. And again, you, the audience, we love context. We love answering questions. You have an opportunity to submit questions at any time using the Q&A tab with the GoToWebinar function. And we'll try to get to as many as possible at the end of this webinar. This webinar is going to be recorded, and we're going to send an email with a copy of that recording as well after the event. So we're going to, kind of clip off the front there, send it out to you in the next few days after this live recording. So yeah, let's jump in. Let's bring out the guests of honor. As Peter's joining the screen here, I'll give a quick introduction to myself. My name is Greg Paulsen. I'm the Director of Applications Engineering at Xometry. I'm kind of the person you talk to when you're working in the phase of help me choose which process or which material and why should I go that direction. So I've spent most of my career of 15 years working in advanced manufacturing, whether that's been additive manufacturing, molding, machining, laser and sheet cutting, other fabrication techniques. I just like making parts. I like being in that environment where I work with both customers as well as suppliers. And along the way, I've burnt my hands on many a stovetop and built tools and resources. So you as a customer or designer or procurer don't need to, hopefully there. And just love talking about customer success stories and some of the projects that we've worked on. Peter, I'd love to have you introduce yourself too, because we have a special co-host and guest here, Peter Simpson from the Autodesk Fusion 360 team.
Well, first of all, thank you very much for having me. It's good to be able to talk about this, and it was a super fun project to be involved in. So my name's Peter Simpson. You may be able to tell from my voice that I am from the UK. I'm actually in our London office right now, so you can see a frosted glass River Thames in the background. Very scenic, I know. It's the best I could do. So my job at Autodesk is actually as a customer advocacy manager. So what that means is not only am I expected to be a technical expert in the areas that I kind of specialize in, but my job is also to talk to as many customers as I can and try and gain more information as to how we can make our software better, but from a customer point of view. We're often kind of providing software and making developments, but we want to make sure that we're making the developments that the customers actually want. So my area of expertise is design and simulation. That's something I've been working in at Autodesk for about 4 years, and that whole time has been spent on Fusion 360. So yeah, I'm looking forward to it today.
Absolutely, I'm super excited. We've done a couple of practice sessions, and I mean, it's very exciting to talk through some of these projects and the hows and whys about how we got there. But before we get jumping in, I want to learn not just about Peter and his goals, but about you all as well as the audience. So I'm going to launch a quick poll. I'll give us about 45 seconds or so to respond to this. And this is just for me to understand kind of what your manufacturing goals are as an audience here. So let me get that launched out here. Should be. And the poll is now open and being distributed. And if you guys could please fill in the please go ahead and fill in this, and we're going through. So we got some people voting in right now, collecting some responses. All right, I got 40% voted. Can we bring it to a 60%? Oh, good jump. All right, we hit 60. Can we get it 80%? We'll give it about 10 more seconds or so, and then we'll close the poll. I'll show you the results. All right, let me give this a close. Thank you so much for participating. And we did hit that 80, so thank you. All right, so I'm going to share these results really quickly. You should see those poll results, but we had about 73% of you were looking for low volume production, which I always talk about, in different scales, especially with advanced manufacturing. Low volume production, you can serve a customer of 1 or 5 or 10 or 20. And I always use the example in aerospace where you can put a high value component on every single aircraft in a certain fleet. And you still may be making sub 500 components. They still need to hit the spec, hit your needs, your price points, and work along that way. And that's something that we're very, very strong at here at Xometry. We also see a lot of RP, so that rapid prototyping, as well as a good mix of high volume production, and some of your folks are also looking for new suppliers. So that's great to see. All right, so we should be back here on my main screen. And again, thank you so much for your participation. And the next couple of slides here, we're just going to talk about some context setting here, where I come from Xometry, like what Xometry is. And then Peter, I'd love to learn a little bit more about Fusion 360 before we jump into this project. So Xometry, we are a digital manufacturing marketplace. And what that really means for you, a customer or buyer, is we make a lot of parts. And we do a little bit different than just a single shop would do, because we, as a marketplace, are able to have serve both customers as well as suppliers, and almost act as matchmaker. And the way we do that is by having a technology-driven platform. So with Xometry, we serve over 30,000 customers. We have over 10,000 suppliers, and we have fully managed manufacturing services. So you, as a customer, you could use our instant quoting engine, upload your technical files, so that maybe 3D model, that maybe technical drawings, select from over 19 manufacturing processes, specify quantities, need times for this. And a lot of times you're going to get an instant price. We use AI and machine learning to provide that pricing and lead time, and you can just make a buying decision right then and there. For our suppliers, we're connected to 10,000 suppliers, domestic suppliers, as well as a global supplier network. And for them, they are able to see work that's relevant for them. Like, you ever see a Netflix score where you're watching Netflix and it says, hey, there's a 98% chance that you'll like this movie? We kind of work with that with our suppliers. We're able to look at the scope of that project, look at those constraints, and those suppliers are able to see the work that best fits them, and they know they can do a great job with and deliver on time and to spec, and they're able to take that job right away. So revenue on demand, as well as a new source of business for these suppliers. With us, by using that digital matchmaking, it helps assure quality over our deliveries, as well as gives you essentially a self-healing supply chain. It's a huge solution. We have distributed manufacturing. You have geographic dispersion of manufacturing resources. So things that may shut down a typical shop, it's just 24/7, press buy and get going with Xometry. So you can give us 1,000 jobs tonight, and we can start 1,000 jobs tomorrow for you.
Yeah, so a bit of context about Fusion 360, because I'm aware that some of the people in this call may not have heard of us, may not have used Fusion 360 at all. So what I think makes Fusion so kind of different from other CAD softwares, or rather computer-aided engineering softwares, is the kind of collaboration aspect that we bring to it. So we've enabled kind of the ability to harness cloud-based computing and cloud-based kind of software in order to give a better collaborative experience for everyone involved. And I think that's another thing that was kind of really personified by this project. It allowed us to actually use a lot of that collaborative power. You had me as a designer based in the UK, miles away from where Greg was, but we could share files instantaneously. And the other thing is our kind of integrated process. So if we skip forward to the next slide, I believe we should have, there we go. So this is what I was kind of meaning by integrated process. So what we're passionate about is allowing end-to-end product development within our software. So we don't want to be in the days where you have 16 different software packages depending on how you're manufacturing it, or what spec your drawings need to be. We want to have everything within Fusion. And I don't want this to sound too much like a sales pitch, but this is basically what we're trying to champion here. So we want everything to be done under one roof in one piece of software, so that gone are the days of people needing a bunch of different memory sticks with different software packages and different ISOs and stuff like that on. We want it all to be under one roof.
Yeah, and I know when we were discussing this earlier, when I started off my career, I worked in a integrated working environment where you had your EEs, so electrical engineers, your MEs, and there's always this fight. The fight for space. Like the mechanicals are saying, make it small, make it smaller. The E's are saying, I need more space, and kind of this back and forth. Myself, as the prototyping guy, I'd usually be making mock-ups on a daily basis, even 3D printing out actually the PC boards, just so the mechanical engineers could get reminded about what they need to design around, and in a physical reality. It's just really interesting dynamics. But that's because you had disparate systems. You had different pieces of software that didn't play nicely with others. So with that, let's just jump straight into the project. Let's talk about this smart badge. In order to do that, though, Peter, I'd love to ask you a few questions to kind of set the stage here, because you're part of like something larger. This is you're with Fusion 360, but I met you as someone that's part of the factory experience. So tell me a little bit about Autodesk University's factory experience.
Yeah, so the AU factory experience is something that is one of my favorite parts about my job. So if you don't already know, we host a conference called Autodesk University. It's our way to try and get in contact with our customers as best we can in person again, which is amazing. And it's our chance to kind of show off what we're working on, get feedback on what we're working on, so things like roadmap discussions, but also show you guys what other people are doing with our software. And one thing that we really like to do there is we have the AU factory. So the AU factory is our chance to do an end-to-end workflow. So I've just been going on about how we can enable end-to-end workflows in a software, but that's all well and good talking about it, but we want to actually do it. So the phrase that we always use is either drink our own Kool-Aid if it's my American colleagues, or eat your own dog food. So we like to test that entire workflow, and we do this in the AU factory. So we get machines on the shop floor of a convention, which, unless you're kind of going to an IMTS or a trade show, it's not that common at some of these kind of conventions. So we get these machines on the floor, we get them moving, we get them cutting metal, printing, whatever they're doing, and we try and show people that we're actually working through the exact same workflows that they are, and we try and stay as relevant to the industry as we possibly can when we're doing that.
So with that, you have this factory experience kind of showing how something's made. What brought you to this, this smart badge design here? Why a smart badge in the first place? But tell me a little bit about that.
Yeah, so I guess let's start with what is a smart badge, because maybe that's not something that everybody's aware of. It's kind of a phrase that we've been throwing around for a year or so, and we've been working on this, but maybe it's not the most common thing to hear about. So the idea was that it was a name badge. So you could load up your name and your email address onto this, and then it would be a way to displace physical business cards. Now, I said this to Greg yesterday, and he immediately pulled out a wad of business cards that you got from his most recent couple of trade shows. And this is what we're kind of talking about, in that you always go to these places, you get a bunch of trade show cards, and maybe you refer to them, maybe you don't. So our idea was to have a sustainable manner in which you could exchange details, but we also really wanted to celebrate the fact that we were back in person for the first time in 3 years. Obviously, there was a thing called COVID. We don't like to talk about it. No one does. but it meant that we had to go virtual for 2 years. So we really didn't get that same level of experience that we wanted. So we were trying to celebrate that. And so what we actually had is what we called a contactless handshake. So between these two devices, you could kind of plug them in with those little kind of joints that you can see at the top. And that would enable you to actually just exchange details with that person. That would then,
This is my
there you
little
go.
demo here.
Perfect. And that would allow you to exchange your details without the need for, printing off a bunch of cards and potentially wasting that material as it falls into someone's desk drawer for the next eternity. And our idea was to try and celebrate that in-person kind of aspect, because we were so happy that we could get back out there and integrate with our clients on a one-to-one personal basis, that we really wanted to design something to try and enhance that experience as best we could.
Yeah, and this is, just to reemphasize, what's cool about this is it's a show and tell and do experience at the factory experience. So what the folks that were going through the factory experience AU did, they weren't just given these badges, they were given the stories as they're collecting the pieces and putting them together. So you kind of see this little tray here with these components working through. But we showed you the end project, but you were talking about, the product development process. So walk me through the development process of the smart badge, just kind of what your stages were like there.
Yeah, so this is actually one of the areas where we changed it for this time around. So previously we've used kind of a standard waterfall type product development process. So, we've mapped out what we need to design. One design feeds onto the next design, and subsequently all designs are kind of created in this waterfall so that everything trickles down slowly until you get to your final goal. Now, with kind of developing / problems in supply chain, a lot of our customers had kind of voiced that they were moving to more kind of agile product development processes. So things like sprints, where you could more quickly make changes and there was less kind of downstream issue, because effectively every, couple of weeks or so, you had a product that was almost ready to ship and you were just making small changes after that in each sprint cycle. So maybe you were changing certain aspects of the aesthetic or this, that, and the other. So we went for this kind of agile sprint-based process, which also kind of was a little bit cheating, because it's something that we use in software development quite a lot. So we had quite a good knowledge of it. But that's what we just decided to use. So that enabled us to basically iterate through this in a very rapid manner and have our whole team, so electrical engineers, mechanical engineers such as myself, working on the components at the same time to harmonize on a product every, I think it was about 2 months our sprints kind of lasted. And then what we could do is we could just keep feeding that back. We could all get together, review each sprint and say, what do we want to change? What can we do better?
Yeah, and you can see here that, the iterations kind of wildly changed over time with your approaches and what you were doing, and especially once you got closer to the final product that you could see here. So this is kind of early stages, and you during these stages you were taking advantage of in-house resources. You had some 3D printers on your Autodesk. You have resources. You have 3D printers, some in-house fabrication services, and working through. So my next question for you is, why did you seek out Xometry? So you had this, you had some in-house services. So what kind of drove that relationship?
So I think one thing that we really like to do with this whole kind of factory experience is bring in partners. So we have a partnership between Autodesk and Xometry, and we like to not only showcase what we can do, but we want to showcase what our partners can do, because ultimately we're partnered with them for a reason, because they're at the cutting edge of whichever field they're in, and we want to enable their workflows to be enhanced by our software. So number one was that partnership, and number two was also we had quite a different scale, let's say. So we were talking, 400 to 500, but because of the way in which we wanted to integrate loads of different professional level workflows, a lot of people, when you're talking 400 to 500 injection molded components, might laugh at you and say, what are you doing? So we needed someone that could not only turn that around in quite a short period of time. I think it's fair to say we maybe put a little bit of pressure on you guys with that, with the finalization of our design and then the proximity to the actual convention. But we needed someone that would kind of listen to us and take all of those factors into account and was happy to just work with us on this. And for that, Xometry was perfect. You guys came in, you listened to exactly what we wanted to do, and you got it done. And that was the main thing. We got there, every part was there, every part was ready, and it was to a very high spec, and it's exactly what we needed.
I'm gonna do a little dance right now. All right, yeah, no, it's we were super happy with with this project, and yeah, I think it was just really cool. One of the things I want to talk about too is how we had more seamless communication. Because you mentioned this before, we did have, we had some Fusion 360 collaboration using collaborative tools, so we're able to see revisions and changes, some annotations, and so instead of just describing something, we're actually able to see that in real time. But also Xometry has an app for Fusion 360. So this is an app that you can find on the 360 App Store, and it gives you access to the tools that Xometry has on its website. So that includes pricing, design for manufacturability feedback, including visual DFM. So actually seeing things like thin walls, sharp internal corners, context-specific feedback based on the manufacturing process you selected, that's available on this. You're also able to kind of add cost as an independent variable during your prototyping phase. So instead of going way down the line with one design approach and then saying, ooh, I hope it isn't too expensive, you're actually able to get that feedback along the way. One of the other cool things that I thought you and Jonathan did very well. So Jonathan Odom, who I want to give a massive shout out to, also leads the factory experience, and just was fantastic to work with, both throughout this product development process as well as during the day of events when we were out there. But when you use the app for Fusion 360, there's a little button that says continue to Xometry, and what that'll instantly do without you click dragging and uploading and going to the Xometry site is it'll just jump you straight into the Xometry.com website where you can see your parts and continue to configure, as well as for me, it's a great way to technically communicate. So you can add your notes, any technical drawings, and we could jump in really quick and assess, address, and get something made. So we worked through some iterations there with you all, and it was very seamless using software to software communication. Now, the first part of this project and the main bulk of this project, the thing that drove lead time and we put a lot of our solutions against was injection molding. I wanted to spend a couple minutes talking about injection molding and Xometry because it's a little bit of everything. Because we have such a diverse supplier network, we're able to celebrate the sweet spots of each of these suppliers, whether they are a low volume domestic prototype molder or international quick turn molder or full stainless steel production tier one automotive molder. We have those options here at Xometry. So we're really listening to our customers, understanding time, scope, cost, looking at technical drawings and needs, and developing a strategy based on that on how to approach the injection mold project. But because we are a digital manufacturing marketplace, if you can source a material, we can source a material. Like we are able to hit the vast variety of resins, polymers, elastomers, even silicones. We have expedite standard economy options. Actually, what will be useful actually for the next factory experience was we just launched quick turn injection molding, which is even quicker than the quick turn that we're talking about today, where you can get quotes very, very quickly, as well as getting parts sometimes in a sub week. That's usually a very simple part, but it's still something very possible now. And again, we work with a very tailored approach. So the quoting site allows you to kind of start that love letter to your manufacturer. This is what I intend to have with this product, but we're able to work through design from manufacturability feedback all the way through tooling kickoff and strategy. But you can see here just a wide variety of options that we can do with our molding services. So we got your files. You sent them over to us, and we put them in our process. And the very first part of our process is we work on getting budgetary quotes to you, and in parallel, we give design for manufacturability feedback. In a product development process, I really recommend if your intention is to move to a production level manufacturing like molding, start talking to us about that while you're in that iterative prototyping phase. It allows you to make design changes that will make it much easier for you when you move to molding while you're still doing those iterations. This was some of our initial molding feedback based on the first designs we've received. But we usually go through what I call the molding trinity. That's uniformity, undercuts, and draft. And as well as this case, we highlighted some other features that would actually improve the assembly of these two halves for your smart badge. Um, the first one, when you use some of these tool extensions, right? So you already had pretty adequate draft within your design extension. And I think we maybe found like a little minor thing about draft for that, but draft is necessary for the ejection of parts without scraping along the edges. You need a little bit of angle based on the direction of pull. So when your mold is closing, you're injecting hot liquid plastic into it. It cools in shape, and the mold has to open up, and the part needs to release without dragging against the walls or without being deformed. And draft is absolutely critical for the process. But I think you guys did an awesome job there. And overall uniformity, which we talk about, is wall thickness, and it's relative wall thickness. So there is a thick limit for sure on it, but it's more about how plastic cools in the mold that we're really worried about. When you have uniform wall thicknesses, the whole part, when it's cooling that mold, shrinks at a consistent rate, and you have predictable results. When you have thick areas, that shrinkage may cause warp or sometimes cosmetic blemishes that we call sink. So on this design here, let me see if I have a part in front of me. You had some boss features on the design. And one of the things when we did a sink analysis, which is an analysis tool that we have at Xometry, we found some hot areas. And this is where on the other side, on the cosmetic face, it would show kind of a little donut shaped, depression, a sink mark on those parts. One of the things that we recommended for you and we implemented for this part design was a little boss trick. So this is something we also have in Xometry's design guide for injection molding, but it's a way to you actually remove material in the CAD design. So just imagine like a third of the thickness down, a little kind of wedge cut out under by the boss, and by doing that, it essentially makes the pool of the resin when it's cooling not on that cosmetic face, but within like the thick boss feature instead. So it reduces the blemish on that part. It's just a nice little trick. And once you learn it, you always use it, essentially, when you're doing molding design projects. And the last thing, we called out on our initial DFM was the mating lips for this. We originally had them, they were originally just flush to flush. And with that, that meant the only indexing for this part when you're assembling was the four plastite screws, so thread forming screws, which isn't bad, but in assembly can cause a few headaches. So one of our recommendations was adding a little mating lip feature there.
And if I can just jump in here, I think this is where kind of you guys coming in and helping us out was so invaluable, because in our software we have tools to analyze draft and thickness. In our product design extension, there's even the design advice feature that allows you to basically check for injection molding. It will give you knife edges, undercuts, draft and thickness variations. So that will all tell us, is it a good part to be molded? But it's what I would kind of refer to as these little dark arts / rule of thumb features, where it's people that have been doing these moldings for so long and have all these little tips and tricks. And that's where it really kind of like elevated this part from an injection molded part to a good injection molded part.
It is true that there is still, especially when you can't argue with plastic, so it kind of does its thing. So a lot of it is learning tools of the trades. I usually say tribal knowledge, not dark arts, but yeah, it is definitely in the same realm there. Essentially anything thermal, by the way, you kind of have lessons learned along the way, but that's why we have our application engineering team, master molders and technical experts in-house at Xometry, is because we need to be ready for this to approach project regardless of the scope or size. So in this case, here's the basket of considerations that you all handed to us. So you had two parts. You had the front and back half. Good news, undercut check, no undercuts to it. So would be a simple A/B mode, which means just you have your core and cavity side, and you don't need anything creating side features like inserts or lifts. And they are also similar volume, which plays very important in this tooling strategy. Material, so Autodesk for the factory experience, we did make the smoke gray. Whenever you see me with the blue part, it's because we also molded some cool Xometry blue because we like Xometry, we like blue, so we had some of these parts too here. And standard finishes, so SPI finishes, which is a pretty standard mold classification. What's nice is it doesn't require outsourcing. So for example, if I have a mold texturing, it requires a secondary step that will increase lead time of the mold. So SPI helped reduce lead time there. And as you mentioned, it was a lower quantity need. So we did, I think, about 450 total sets of these parts, so front and back half. And in this case, it was a one and done, where you had these parts for the factory experience for the users to assemble these kits together. But after that, although you could reorder at any time with this mold, so just want to leave it open, Peter, if you ever want to design something else or have more smart badges, mold's all yours. But we engineered the sale with you to hit your budget and lead time based on this total encompassing cost, tool cost plus part cost. How do we minimize it while hitting the quality of work that you are looking for? And I want to dive deep in this because people sometimes think that molds are just two big slugs of metals with a cavity carved out of them, and they're much more engineered than anybody anticipates first time. So what's really great about this project is we did document a lot, knowing that we were going to be talking about this. In this case, I'm able to actually show off the actual mold. So this is kind of the mold together, if you will. This is the actual mold that was used to produce these parts. And we did create a shared family tool. So this is a multi-cavity tool where the parts had a edge gate. So if you look here, this little feature right here and right here is where the plastic gets injected in the cavity to make these parts. This shared feature in the middle is called a runner, and it's where it basically diverts where the plastic is being injected into the parts itself. In this case, it was a shared runner. So we're injecting straight in the middle, straight through, little sprue design. And this little curvature on the runner helps create predictable shear, which is kind of how the material is flowing into those parts, and then fanned out and flew and went into the part cavities, create those pieces. So immediately we are sharing a tool. So reducing your tool count, which is a huge cost driver, down to one tool there. Now you still have to pay for the cavities, so it doesn't necessarily split your costs in half, but it does reduce the overall cost of this parts. And luckily, because the geometries are very similar, we could just inject straight in the middle and get you great results on each side there. This is what the core and cavity side looks like. So the cavity side would be where the depression is. The core side is obviously where you kind of have this um, like embossed feature, and the material was injected straight in the middle, went through these cavities, and filled this out. One of the things I want to show is that this is a complex machine part. For example, the text required RAM EDM to produce. These are precision machine components because they need to hit flush with each other. There's many indexing features across this tool to make sure that every time it closes, it creates a repeatable result on this part. So that's kind of the superpower of injection molding, is you get the same part every time consistently. And here you can see even little machine paths for what we have is called venting. So venting is extremely important in injection mold tool design. When you are injecting that plastic in, it's filling up a cavity and the air needs to go somewhere. If you don't vent your tool, what's going to happen is that air will get under such high pressure that it could combust. You'll create a little plasma and you'll actually have a scorch mark on your part. But two, very common, you'll get incomplete features. So essentially that air bubble fights back against the plastic flowing in and almost acts like a rigid object and creates kind of a freeze off point where the plastic hardens before the feature is created. So again, I was super happy. Like this is a very well designed tool, and it kind of shows a lot of the love and care that we put into our mold making efforts. Something else to note is that when we are ejecting these parts, so if you ever look at a non-cosmetic side of a part, you're going to see little kind of circular features. And let me see if this light picks it up here. You kind of see that one circle showing there. But those are ejector pin locations. And we need to add enough ejection that the part is evenly pushed away from the tool every cycle. If you have too many pins in one location, or too few, I should say, in another location, you're going to actually bend the part and cause warp and deflection because it still is warm. It just was molten plastic a few seconds ago. So it's still a warm part. So you need to gently remove that part from the tool with these ejector pins. And that also includes the runner. So there's actually ejector pins here that are pushing the runner out as well in this process. The other thing to notice too here is you can see that ejector pins don't always need to be on directly flat spaces. You can see there's areas here on the bosses, as well as they'll get milled, essentially ground down to shape, flush with the tool. So you could hit kind of the curved faces. So that's something that is done during the tool making process. And when you put it all together, the mold has some other aspects to it. So this is, I showed you the core, the cavity, kind of how that mold is laid out, as well as the ejector locations. We also have things like the sprue orifice, which is where the auger that's melting the plastic down and injecting it in, that's where all that action happens. So that's kind of happens right at the tip of this runner moving down into the part itself. Also, the tools are cooled. So when you're injecting hot plastic in a metal part over and over again, it would heat up. What you do in molding is you're running a cooling line through those tools. So they'll essentially have zigzagging channels going across that tool to keep it consistently cool on both sides. And that gives you, again, even consistent expectations. Like the first part molded is the same as the last part molded with this process. And this tool is fully automated. So each of the tooling cycle, was able to just run through, make a part, drop a part, make the next part, and move through. Because you didn't have any undercuts or side actions, and say, for example, we needed to add a hand load, hand-loaded cores to make some side features would require a manual manipulation, and so you have to stop the tool, take out the part, replace the hand load, run the tool again, pop out the hand load on the part, and move on. But in this case, this tool actually, because it's AB, is actually very automated. So Peter, again, if you want to order 40,000 more of these, I probably could do that for you here. And again, because it is a shared runner, those are mainly removed after ejection. I'll show you what that looks like in just a second here. So I'm going to bring a video up on screen, and this is the tool being made here. So give me a second. Sorry, the tool running. So this is the actual tool for your parts running in action here. And I have it silenced because it is in a shop, so you'd hear air compressors and other loud things, so we'll kind of narrate through. But you can see here that the operator is running the tool. The tool right now has already injected plastic, and it's kind of packing and holding. In a moment, you're going to see the tool open up. So that B side kind of slides away from the A side, which is connected to essentially your injection point for the plastic. And robotic gripper is going to come in and drop the joined parts together. So you can see the parts are still joined with the runner, that shared runner. This is where it goes into review and inspection. So just taking a quick cosmetic look. And then you're going to use die cutters to kind of remove those. So most of the time, edge gates are removed with die clips. So it gives you just a nice flush clip there. And off camera, there's someone that's also verifying just measurements, just kind of checking the measurements before they go in the package. Meanwhile, while that's all happening, the part's being made again. That's the power of injection molding. It is a fully automated and repeatable process. When we made these parts for you, Peter, the very first thing we did once the tool was completed was we sent out what we call T1s, which are the first 10 samples, the first 10 good parts off the machine, and got some feedback from you all. I think the only thing we did was change the tint slightly of the smoky gray on those parts, and then we produced the rest of them. So usually the injection mold cycle is we kick off that tooling with you. We'll make it we'll go and make the tool itself, and then run those T1s, do any minor tweaking. Sometimes that's called tool grooming. Sometimes it's good to go. We get the thumbs up. The next run is the production run. So I think we got the T1s in a sub 3-week time frame for y'all. Got a very quick okay, and just started running. And the next time those parts were opened up, were in boxes down in New Orleans for the factory experience. But the story's not over. So we still got about 2,000 other unique things that we needed to make for the factory experience. And that has to do with these buttons and interfaces. So the bevel design here, these mating interfaces, the two buttons are all unique designs and parts. Now, if we did the same approach that we did with the enclosures, each one of those would likely require a tool, or at least I would predict at least 4 separate tools, because the buttons could probably share some space there. And that's where cost would not work out, cost and lead time. Especially with these designs, because you had poka yoke style designs, so they could only be assembled in one unique way. And you could also see kind of varying thicknesses, and uniformity wasn't there because these were designed with a 3D printed solution in mind. And just kind of tell me a little bit about that, and I'll tell you kind of what we ended up doing in the moment.
Yeah, so this is another thing that's maybe a bit different about our kind of workflow is one of the main things that the customers who actually come to the factory are doing is putting together the name badge. So we want to make that quite an interesting process, and stuff like Poka-yoke is a great way to enable. So number one, we wanted to make sure that everything could only go one way, because there's nothing worse than having 400 of these and ending up getting rid of some because people are putting things on the wrong way, or potentially things are confusing and they're hard to put together. So we wanted it to be simple yet interesting, and Poka-yoke really played into that. So we really needed to harness some kind of flexible material. And we had a few different fixation kind of methods where, one of the parts would come in and it had a little kind of flexible arm that would pop in underneath this screen, nice and snug there.
I think I got that piece right here. Yeah.
There you go. So that would kind of pop in one of the holes that was on the screen, kind of where it was fixed down to the PCB. And then, we wanted nice tactility. All of this kind of process was geared towards the actual experience that people have when they're putting it together. So I think we maybe threw some slightly too Poka-yoke, or slightly too maybe focused on the customer experience kind of parts. But again, we asked you guys, you said, we can do it. We'll send you some parts, and you sent us some parts, and they fit together perfectly. And overall, we were happy with that kind of whole process. It's the same thing that happened with injection molding, like you said. All that we changed was the tint of the actual kind of frostedness of that actual part. And for this, all that we did was really say, hey, that's perfect. Let's run with it.
Yeah, absolutely. In this case, we chose multi-jet fusion for several reasons as the final results. But we did look at things like carbon digital light synthesis, which can create a elastomeric polyurethane material. We looked at polyjet, which could also create a rubber-like photopolymer material. But with multi-jet fusion, these powder bed fusion technologies for plastic, you're creating something in a real thermoplastic, or thermoset, or sorry, thermoplastic, I should say, yeah, a real thermoplastic design, and you get those real results. So this TPU material is shoe sole rubber tough, like it is the end use. Like you're not, you're gonna have a hard time with wear and tear if you're really trying to damage this. And because I'm using multi-jet fusion, I can actually nest parts not just in my XY, which is going to be like the build plate where you typically see 3D printing with support structures. With this, I don't need support structures. So I can also densely nest this all the way up in the Z direction. So what you see, this hodgepodge of stuff here, is actually hundreds of sets of parts being produced all in one build. And these builds are typically like 18 hours, or fewer, to produce all these pieces, and then afterwards you kind of do a treasure hunt to look through. But this is kind of the power that you have with industrial 3D printing technologies. This is not a desktop 3D printer, and we produce over 2,000 parts in a sub-week time frame with this process. So only after a couple builds, and you're producing all the components needed for this project with their unique needs. So I have another video here showing what the multi-jet fusion process post-processing looks like, because watching it is kind of fun, but it's not, you don't really see like the shapes like you would on a desktop printer. But this is the treasure hunt here. So this white material is unsintered TPU material. They're using kind of a vacuum with a little strainer filter on it to find individual pieces, and we call this rough breakout. So we are taking these pieces, we're using brushes and kind of removing as much residual powder as possible. Some of that powder can be recycled and used for subsequent builds. From there, these will go into a finer breakout, which is bead blasting to remove any excess material. And then the only secondary process we did on these designs was we dyed them black for a consistent look. But you can see how densely packed all these, chock full of little components. And what this technician is doing. Oh, and I'm running my I am run again. But what the technician is doing is they're breaking that out in that rough breakout section. So it is a really great way, especially when you have a high diversity of work. In this case, that limited run, high diversity of stuff, same material, family build it any day of the week, using additive manufacturing. So this is a great time. We're about 15 minutes till end here. Get your questions ready. I see a couple have already come in. Use that GoToWebinar tab, and we're going to get to those in just a moment. And we're just going to overview some of the hows that we used along the way with our different platforms. And the biggest platform I want to emphasize is the Instant Quoting Engine. 19 manufacturing technologies with just the upload of a 3D file. It is really, really powerful what Xometry has made for your sourcing and supply chain needs. You're able to specify quantities, your process, materials, features, finishes, and go down that list. Whether it is 3D printed production, whether it is injection molded, low volume production, if you're looking for CNC machining, laser cutting, and sheet cutting, like even gasketing material, that can all be done on our quoting engine with just a click of a mouse. And it's really, really powerful because you're able to see that pricing, lead times, press go, and we consolidate your supply chain. We have suppliers on our network with a huge diversity of skill sets. So whether it is, in an ITAR compliant aerospace device or a medical device or a prototype that you're just iterating through and you just need as quick as possible at a low cost as possible, we have all those options on our quoting engine. I just encourage you to check that out. If you are in CAD instances, and Peter, look away really quickly here, but we do have CAD add-ins for Autodesk products as well as other popular CAD. So Inventor, Fusion 360 from Autodesk, both have apps and add-ins available for them, as well as we have add-ins for Onshape and SolidWorks. So we want to meet you where you are in your design experience. And with each one of these add-ins, you have the ability to, again, see pricing, lead times, move to Xometry sites seamlessly without having to click, drag, and upload through. And actually, with the Fusion 360 and Onshape, those are our most recent apps, they have the ability to give you that visual DFM. So I can show you, so this one, for example, is CNC machined, and it's showing you sharp internal corners. So having that visibility there, you're driving, you're in the CAD seat, right? So you're able to make a design change right on the spot using these apps, and they're completely free to use, and just encourage you to use those during your design process. Even just understanding costs, understanding design changes, it never hurts to use that. And of course, we built a lot of resources. I've built a lot of design guides and tools along the way. As I mentioned in my introduction, we've seen a lot of manufacturing, and we want to make sure that if you are in that design phase, you have a lot of tools available to you, but we want to give you as much as possible to prepare you for something you may not be familiar with. If you're the best CNC machine part designer in the world, maybe you need to learn more about injection molding. If you're moving to those projects, you can go take a look at one of our design guides or watch one of our instructional videos or webinars on that, or even check out some of the case studies that we have for inspiration. So I really recommend checking out Xometry's online resources. Our solutions pages per manufacturing process we have are really thorough, and we have design guides, blog posts, and videos as well to help supplement that. And it's time for a shameless plug from our co-sponsor.
Hey, I always got to be here for the shameless plugs. So what we wanted to mention is that we are actually running a Fusion 360 promo at the moment, which is 20% off Fusion 360 and the extensions, and you can access it via that QR code. I wanted to kind of bring this up because, especially with this project in mind, we did use a few of those extensions because they allow us to really focus on plastics. So things like the product design extension enabled us to have a one-stop shop in design advice to analyze our part in terms of injection molding, as well as some design automation strategies. We also use things like our ECAD, and we have things like the signal integrity extension associated with that. And then one of the ones that I like the most is a simulation extension and the ability to actually do a part level simulation of your injection molding process. So, when Greg was saying that these parts were kind of balanced and they were doing all of these different things that enabled us to make a easier molding process, not to blow my own trumpet, but that was by design. We were trying to make it the best we could. Admittedly, I maybe missed a couple of things along the way, but hey, human error is a wonderful thing. So if you want to get involved, this will be running through till April the 25th, and you can access it via that QR code.
All right. And with that, I think, and I got the QR code right here. So if you didn't snag a picture of it, you have it right there. As well as with Xometry, save $25 on your first order of over $100. Definitely give Xometry a try. This is if you already use Xometry, give it try a new material or something you haven't used in the past. We have so many to offer, even under 3D printing services. We're around 100 materials or so. So there's a lot to choose from, a lot of options available. I see some questions going in, so Peter, I'm just going to jump right into things and let's get going. So the first question is from Guy. This is actually earlier on, and they were just talking about difference between low and high volume production. And I think we mentioned that a lot during this webinar. But what we made for you are production components. They went into customers' hands. They were assembled, and we wanted to show off the best, right? We wanted to show them to look at this and be like, hey, that's pretty cool. And the quantity was still, 400 to 500 sets. So in the injection molding world, that is pretty low volume production. It's where most of the times, if you're looking at just the stuff around you, like the pieces on my headset or anything plastic, keys on your keyboard, those are made in the millions, often, or at least the hundreds of thousands. So the considerations are very, very different in how that tool and design is approached, and even how cost amortizes from that tooling cost. And so that's what we really look at with the solutions for low and high volume production is understanding like that there's some that really start with minimums of the thousands of 10,000s, and there's other technologies that have sweeter spots in a lower range. The other thing I'll mention all the time is machine parts. You can serve a customer of one with machine parts, and you can skip out on quality specifications, tolerances, inspection reports, documentation, material certs, in a lot of industries like aerospace or defense. And that is a production component, but again, it would be in a lower volume versus moving possibly to, for example, die casting, which Xometry offers, where you're usually starting in the low thousands and moving way up from there. So I'll give a quick answer. What material was that tool made out of? So we did an international manufacturing of that tool that was P20 steel. Usually our domestic quick turn prototype molding would be an aluminum, like a 7000 series aluminum tool. But because we made this internationally, steel is actually the typical go-to for tooling out there. All right. So I got a question, Peter, for you. What would you recommend is the best way for someone that has a product idea but doesn't have design experience to get the process started? So going from that concept all the way to, let's say prototype one.
Yeah, so I mean, I maybe come at it a different way to maybe some design specialists, because I have a mechanical background. I have a mechanical engineering master's. That's what I studied. But my idea is always like, if it's something new and innovative, look at what things do similar, kind of like what options are out there that do similar things, or maybe just other mechanisms that could work, and maybe try and kind of like look at those and use those as inspiration. I always like to do a mood board. I know it's a bit cliche. I know it's a bit overdone in the design world, but I think it really helps to not only focus on the aesthetics, but the actual purpose behind it. Look at your target audience and who you're selling to. And then for me, and again, I'm going to be biased here, but I think Fusion is a great starting point. I think it has a great set of learning online. So we have self-paced learning, we publish YouTube videos, we have forums that are manned not only by Autodesk personnel, but actually by members of our community called Expert Elites. And so they will give you an unbiased view. They are not employed by Autodesk. They have their own jobs. They use Fusion in those and are so good that we have kind of given them this status as because of their help on those forums. But in my opinion, it's the perfect place to start because you can look at everything. You know, if you're going down that product development line and you decide that maybe you need injection molding, you could simulate your injection molding. You could check your design for injection molding and use some of our design automation along the way to help you out. It's kind of a good way to kind of, you start at that real concept level with something like a mood board where you're looking at who are you potentially selling this to, what problem is it solving, what do you want it to look like maybe, if it's something that is going to be handheld, and then just take it through. I think the earlier you can get into kind of CAD and start looking at it in a three-dimensional sense, even on a screen, the better. And bringing in people like Xometry to get prototypes made, get them in your hands and actually seeing what's on that screen, because sometimes that disconnect is between a prototype and the screen. And we're aware of that. That's why we want to enable a lot of those workflows. So I would say always start very simple. Who are you selling to? What are you doing? Go into your software, start making some mock-ups, and then try physical prototyping, because that's ultimately the thing that's going to make you realize, oh, hey, I accidentally put an extra zero in the scale for this, and my handheld device is the size of a car or something.
And you know, I can't emphasize enough, even like with other tools beyond CAD, I usually kind of mix media when I'm doing early stage prototypes. It is super important to get something physical in hands, and 3D printing really helps there, especially as you add more complexity into your design, because it is fast. You know, most of our 3D printing processes start in about 2 business days and have free shipping. So you're gonna get parts in hand very quickly, and those are parts you could share also with your potential stakeholders. So as you're working a design, you can start getting that iterative feedback really quickly. So I had a question actually when I mentioned that we did international molding for this. In this case, it worked with budget and lead time. There definitely are cost differences so the question is, where the parts manufactured in the USA or internationally. In this case, we chose international, again, just so the budget and the lead time still fit with what your requirements are. You get to see that though. Xometry is a marketplace. You get to choose if you were looking for a domestic, quick turn, domestic run. That's something where you can clearly, explicitly see those choices, and you're also able to see those price comparisons. And a lot of times it is less expensive for you know, a small trade-off in business days to move internationally. But also there's a lot of work. For example, when we work in ITAR or export restricted environments, we still have plenty of resources here to get the job done, whether it is at low volume prototyping or production stages. So we do a whole wide mix of locations across our network, but it's always visible to you as the customer. You're able to see tool origin, make origin on any project we do. So another question, just getting involved with Xometry, you know, when you upload a design, is there an NDA involved? So we do treat every project confidentially. We wouldn't be in business if we didn't. So we do have our standard terms and agreements and we're never going to talk about a project or discuss it with anybody else under those agreements. This is why I like this webinar, because we actually get to talk about a cool project, because we barely get a chance to in our day-to-day career. If you do want an NDA though, Xometry does have a template of mutual NDA. So if you search in our search bar, you'll be able to find the NDA, or if you go to xometry.com/legal, you'll be able to find our templated NDA, send it out to our support team, they'll get it signed and executed back to you. So definitely that's something that we do every single day. NDAs, vendor agreements, anything like that, we're always happy to work through. And support@xometry.com is going to be the best catch-all for that. Let's see. Got time for one last question or two. So how in depth do we go into mold design? And is it every mold, or is it dependent on the project? So this is a great question for us, because it really depends on both. But it actually is kind of a chicken and egg sometimes. We are always going to come in with what our strategy is going to be based on your selections, so domestic, international, the variety of parts, the quantities of parts, the materials of those parts coming in, and we're going to start getting a rough order of magnitude cost for you. One of my most important questions for you is, what is your estimated annual volume? So you may be ordering 750 in your first run with injection molding, But if it turns out that you need, 3,000 a week for the next 52 weeks, it's a very different story than if you're like, hey, and then I may do the similar reorder next year. And that's going to change our tooling approach and strategy. When we provide you our first estimate we will give you design change or design for manufacturability feedback with our estimates, and again, start that early, start it while you're prototyping through. But we're going to tell you what our approach is based on what we heard, but we're always happy to work back and forth with you and update our approaches and experience. It is until we after order, it is until about 48 hours after order that we really start kicking off the tool, which means giving the okay to cut metal, because we want to make sure that what we think you want made, what you think we're making, and what our supplier thinks they're making are all the same thing. So with molding, when I machine a part or 3D printing a part, it's dating. It's very quick, iterative responses. Molding is marriage. We talk about it, and we'll work with you. And we have a consultative team that helps work out those details. But every project is a little bit contextual. There's some that are a little bit easier. For example, we created a subcategory for that quick turn injection molding. If you go to Xometry site, you click quick turn, and it has very limited options for materials and processes. But that's because it's kind of like a speed lane for you. So we just know that those are reliable, they're ready at any given time for a domestic quick turn run. So sometimes that happens, but the rest of Xometry it's your oyster, right? You could have what you really need. All right. And Peter, I know we're 1 minute over. Any final thoughts or feedback? And any questions I didn't get to, I'll get to after this webinar as well.
Yeah, no. Number one, thanks for having me. I look forward to anyone reaching out. Reach out on LinkedIn. My name's my name. It is across everything, really, funnily enough. But also, if anybody is interested, there will be a part 2 this year to the Xometry and Autodesk kind of AU factory experience. And I think maybe the webinar next time around is going to have a little bit more intricate molding processes, to say the least. I'm not going to give too much away. We like to keep it a surprise for actual AU what we're making, but we're going to have some really cool molding that we're going to be working on together.
We're super excited, and I think that with this too, we're going to be more we're going to be able to talk about this closer to the time of the event on launching. So I'm really excited about working with you on these next projects. And it's fun for us because it's mixed medium, and we're just like, throw the process at us, we got it all, So it's really happy for us, or we're really happy to be working on these type of projects. And with the Smart Badge, I mean, it just really shows off what you do. I mean, these are 2 very different processes making a very real part for your customers. Peter, thank you so much for being here. To everybody who's joined the webinar, thanks so much for joining, asking your questions, and sticking around, and have a wonderful day. Thank you.
Thank you very much, guys.
Cheers.